Hello there. This is Junaid Ahmed, completed postgraduate in physics, B.Ed in physical science, and I have qualified uh, central teacher eligibility test, and I am certified STEM educator. So before starting the session, just I want to show you, I have here in a extension device, a LED lamp and incandescent lamp. I'm going to switch on this before start to explain my presentation here. Now, let me share my screen here. So this is brief introduction about mine. Now, in this presentation, I'm going to elaborate about light emitting diodes and different kind of materials used in the LED and its different types, and then next level of LED devices here. Okay, this is the thing I'm going to discuss here about the outline of the presentation. The first slide contains introduction about light. So this is the basic properties of light. And then introduction to PN junction diode. What is P-type material? What is N-type material? And how it is combined to form a PN and how the junction diode is formed here. Then based on PN junction diode, then we are going to see how LED works in four major parts: principle, construction, working, and energy band gap. And then fourth slide contain comparison of incandescent lamp versus LED. That is physical durability, efficiency, cost, lifespan, toxicity. So these things are talking with the help of incandescent lamp versus LED. And then fifth slide contains power consuming curve for incandescent lamp versus LED. So this is watts versus luminous. So watts versus luminous. Then material used to make different colors of LED. Then application of LED, comparison with the other LED and comparison with other bulbs. Then point to ponder the next level of LED. The next research thing about LED. So in the first slide contains introduction about light. We know that light is electromagnetic radiation. Electromagnetic radiation is nothing but whenever electron revolves around the nucleus, so it will produce electromagnetic waves. So the electromagnetic waves are transverse in nature and non-mechanical wave, which means that electromagnetic wave doesn't require any kind of medium to transfer from one point in the space to another point in the space. Then in the second thing, we know that light traveling fast, none other particle cannot able to travel faster than light. So light travels 3 lakh kilometer per second. Even we have hypothesis, uh, the particle tachyon, which can able to travel faster than light, but still doesn't have any kind of scientific proof for that tachyon particle travel faster than light. Then we will have visible range of light is 300 nanometer to 700 nanometer. In electromagnetic spectrum, we have gamma raised to waves, electromagnetic waves, but human eye is sensible for only visible range 300 nanometer to 700 nanometer. Then wave and the particle nature. Wave and the particle nature means if we are understand that classical aspect, classical physics, we can able to understand the wave nature of light. Then if we are understand the modern physics, we can able to understand the particle nature of light. The name of particle nature of light is called as photons. So the simple thing here is whenever light travels, it behaves like a wave. When the photons is interact with the object or material, it behaves like a particle. Okay. So at last we will have energy. Energy, according to Max Planck concept of quantization of energy. Light will carry energy as well as momentum. E is equal to h nu, where E is the energy of the incident photon, h is the Planck's constant, and nu is the frequency of incident radiation. Frequency means uh, oscillations per second. Okay, so frequency is inversely proportional to wavelength. So shorter wavelength, higher frequency. So this is all about introduction about. Then we will have in slide is introduction to PN junction diode. So before introducing the PN junction diode, I want to share with you about elements, semiconductor materials. So semiconductor device is a kind of device which conduct electricity if sufficient amount of energy is given to that particular elements. Semiconductor is neither be conductor nor be insulator. It is in the mid-range of conductor and insulator. Whenever electric current is passes through the semiconductor device at sufficient amount of energy, it can able to conduct electricity. So, what are the elements for semiconductor devices? Means the simple thing you can able to remember that those elements having four electrons in the outermost orbit are considered as a semiconductor devices. Here I am having silicon material. So in silicon material in outermost we are having four electrons, and if you want to make n-type semiconductor, that is negative type semiconductor, negative means electron, more number of electron in type semiconductor. If we are adding pentavalent impurity means those elements having five electrons in the outermost orbit is mixed with the silicon material. Four electron makes covalent bond with the neighboring atoms, and one electron is left over here. And this electron is responsible for conduction of electricity. If you want to make p-type, positive type semiconductor material, we have to add trivalent impurity. Trivalent impurity means those elements having three electrons in the outermost orbit. If we are adding in the silicon material, so it will make positive type semiconductor material. So this is the basic things to make PN type semiconductor. So trivalent impurity is a P type semiconductor. So three electron make covalent bond with the neighboring atoms. One is left here, so this is whole. And pentavalent impurity makes N-type semiconductor, which makes four electrons makes covalent bond with the neighboring atoms. One electron is left over here, so which is moved through the material freely. Okay. So then doping means adding of impurity. Here for making p-type semiconductor, we have to add trivalent impurity. For n-type material, we have to add pentavalent impurity. So aluminum with silicon and phosphorus with silicon made n-type semiconductor. Aluminum with silicon make p-type semiconductor. Majority charge carriers means here for p-type semiconductor, positive or holes are majority charge carriers. So this is higher in number compared to electrons. For n-type material, electrons are majority charge carriers, positive or holes are minority charge carriers. So forbidden energy gap in p-type semiconductor is acceptor level. So we know that electron is responsible for conduction of electricity in a metal. So in p-type material, there is a deficiency of electrons, so it needs an electron to conduct electricity. So the energy is in the accepting level, so which can able to accept the electron. So this is called as acceptor level. But in the case of n-type material, which is having excess of electron, so this is donating the electron. So donor level means it can able to donate the electrons. Acceptor level means it can able to accept the electron. So before adding dopant, we have 0.072 electron volt for germanium after adding dopant. So it will become 0.01 electron volt. For silicon, before adding dopant, it will have 1.1 electron volt. After adding dopant, so it will become 0.05 electron volt for silicon. So after adding the dopant, the conductivity changes. How the conductivity changes based on the what type of dopant we are adding here, and the quantity of the dopant is mainly responsible for conduction of electricity. And how the dopants are adding here means, for example, let us imagine if we are having millions of atoms in a metal, we are adding only 1,000 of dopant here. We are not mixing the equal ratio. So just The mixture contains parts per million. So we are adding, if we are having millions of atoms, we are adding dopant only thousands. Okay. So this is uh, the brief explanation about p-n junction diode. So whenever the dopant increases, or whenever we are adding the dopant impurity, so it will change the property of conductivity and resistivity. It is started to conduct electricity in room temperature itself. The next slide, how PN junction diode works. I have a video here. Just see that you can able to understand it. This is N region and this is P region. In N region, we will have excess of electrons are majority charge carriers. In P region, we have holes are majority charge carriers. And these electron tends to occupy these holes, and electron in N region jumps from N region to P region and occupy these holes, and those electron moves from N region to P region, it will become a positively charged particles here. Okay. So, and these positive charges attract these electron, and this electron attract these positive charges, and it will create electric field in between the two regions. Okay. So this region is called as P-N junction or depletion region. Actually, this is the junction. So no more electron cannot able to travel these depletion region because it creates an electric field. So the electron doesn't have sufficient energy to jump this depletion region. So if you want to make to jump this electron, so we have to be sufficient amount of energy to jump this depletion region here. Okay, see here. So this is energy band diagram. This is N region, this is P region. So the electron try to occupy this hole here. Whenever electron jumps here, so it will create a depletion region in between the two regions. Okay. So this electron first occupy this conduction band, and then electron jumps from conduction band of the P region to valence band of the P region. So then it will create an electric field in between the two regions is called as energy band gap. Based on the kind of dopant added here, the quantity of the dopant, so that will decide the width of the depletion region. So more is the dopant, more width will be the depletion region here. Okay. Now, on third slide, we will have how LED works. Principle, construction, working, and energy band gap for LED. So, if you are understand that concept of PN junction diode, the same thing here we are going to discuss in LED also. Now, this is principle of LED here. So whenever electric current is passed through the p-n junction diode, an electron gets sufficient amount of energy in the N region, and this electron can able to jump from N region to P region from this depletion region, and when recombines with the hole, it will produce light. The simple thing here is the N type is connected to the negative terminal of the battery, P type is connected to the positive terminal of the battery, and the electron gets sufficient energy from the source, and the electron gets jumped the depletion region and it recombines with the whole. And when it recombines, it will produce a light. So this is the conversion of electric current into light is called as electroluminescence. Okay. So the simple concept is whenever electron recombines with the whole, it will produce a light. Okay. So it works on the forward bias method. Forward bias means P type is connected to the positive terminal, N type is connected to negative terminal. So this is this should obey Ohm's law here. Then the construction of LED, which is having epoxy lens, which can able to propagate the lights in all directions. So the epoxy lens is almost is a transparent in color. Okay, so transparent color means so whatever LED generates light, so it can able to propagate in all directions. Reflective cavity can able to give the direction to the light here. So this is the reflect the light. Then anode, the length. Though in LED we will have a longer terminal is called as anode, shorter terminal is called as cathode. Then LED chip is nothing but the p-n junction diode is connected, like what we have seen before. It is connected like that. Then bond wire which connects anode to cathode. Okay. Then we will have working of LED with the schematic representation and video also. We can able to understand easily how LED works here. Okay. See, it is connected to positive terminal of the battery is connected to the positive terminal of the LED. Negative terminal is connected to negative terminal of the battery. So this is the symbol of diode. When arrow mark is given outside, so this represents LED. Okay. Yeah, this one. So this positive terminal is connected to P region, negative terminal is connected to N region. So this is depletion region. Whenever this electron gets sufficient amount of energy here, whenever electron gets sufficient amount of energy, it can able to interact with the holes. When it interacts with the holes, it will produce it. So this blue color arrow mark represents emission of lights. Okay. So here also you can able to see this depletion region, and whenever electron recombine with the hole, it will produce a light. Arrow mark will represent here. So this is how LED works. Okay. Now this is simple LED circuit. The positive terminal of the battery is connected to positive terminal of the battery. A negative terminal is connected to the negative terminal of the battery through 1 kilo ohm. Now I have connected with parallel. I have connected multimeter parallel to the LED just to show that different colors LED require different output voltage or different operating voltage, which means that different color LED require different operating voltage. I have here the demonstration section for that. Just I will spot it to that video. One second. For now, the mobile is disconnected here.
Recording in progress.
Yeah, stop here. Going to stop sharing my things here. Yeah, I'm- now this is
Now this is
basic LED
basic
circuit.
LED circuit is there.
Okay. Okay.
Now
This contains a battery and 1 kilo ohm resistor and a multimeter to show the output voltage of this output voltage of the LED here. First, I will connect. Sorry. First, let me connect the violet color LED here. So the violet color LED this is a violet color LED. The output of this LED is 2.98 volt. Okay, so this violet color operates at 2.90 or 2.95 voltages. Then in the series, I will have blue color LED. So the blue color LED operates in the voltage of 2.76 voltage. Okay. Then in the series, I will have here I don't know what color it was exactly. So let me have this green color LED. Green color LED operates in 2.73 voltage. Okay. So as you can able to see that different color LED having different output voltages. Then red color will show. Red color operates at 1.93 voltage. Okay. Then we will have white color LED 2.9 2.83 voltage for white color. At last, I will have here that multicolor. Multicolor means so dancing LED here. So it can able to show different colors having different operating voltages from 3.30 to 3.302. Minimum is 2 point something voltage is there. So this is different color LED having different operating voltages here. So this shows that different color LED requires different voltages. So which means different color LED having a different material. So I'm having the material things also here in my slide. Let me explain this to you. Okay. I will start with the screen. I will share my screen. Okay, I'll share my screen. Okay. So the comparison, let me show this first. So as you can see, red color operates at 1.90 voltage, Okay. And green color operates at 2.7 on voltage, blue color operates 2.76, violet color operates at 3.06, and white color operates 2.82, and multicolor 1.9 to 3.10 voltage. Okay. Then comparison of incandescent lamp versus LED here. So I'm having here incandescent lamp and LED here. So just see this. I'll stop sharing and I will focus myself. So here we are having a bulb here. So the bulb, incandescent bulb. So this is having a uh, two metal thin metal wire is here. So in between we have one of the filament is called as tungsten filament. So this tungsten filament is whenever the tungsten filament is heated by supplying electric current, so it will remove the electrons whenever electron releases and interacts with the gas which is having inside the bulb. When it is interacted with the gas, so it will start to glow a light. So this is the working condition of incandescent lamp. So when we are comparing these two bulbs, so in LED, we are having here a small chip like that, as you can able to see, a small chips like that, and this is one of the ICs there to control the voltages. And so this is a small LED. So if one chip is gone, we can able to remove other LED works simultaneously. So this is connected in parallel. Okay. Now I will share my screen by comparing. I used to compare these two lights here. Okay. So first, efficiency, the input voltage and output voltage. So in incandescent lamp, the input voltage is we are giving input voltage, but 90% of the input voltage energy will get converted to heat. Only 5 to 10% is converted to the brightness of the light, the glow of the light. In the case of LED, it almost uses the voltage, almost 90% it uses the input energy. Now the cost of the latest incandescent lamp is very cheap, 30 to 40 rupees. But in the case of LED, so it is available in 120 to 140 rupees. Quality of the light, both the quality of the light is good. Lifespan, whenever the voltage fluctuation is there, the tungsten filament will able to break up, and then the light after it doesn't in use. But in the case of LED, it will have a different. If one LED is gone, means we can able to remove that, and other LED works normally. Okay. And the case of ease of use, both are easy to use. And toxicity comparison, there is no any kind of toxicity between the two light and on-off durability. Incandescent lamp takes time to bright glow because it electron will remove and interact with the gas particles, and it will glow up because the atoms will have to go from uh, ground state to excited state, so it will take a time. Then physical durability, when the incandescent bulb is dropped down, so it will go down and it will break up. But in the case of LED, it is not there because it is made up of something plastic like that. As you can able to listen the sound here, this is something plastic material, so it can able to withstand that when we drop also, so it doesn't break up. Then we will have power consuming curve. In x-axis watts, in y-axis luminance, that is brightness of the light at 2 watts. So both will flow at up to 100 luminance. But at 20 watts, the incandescent lamp will glow at only 250 to 300 luminance brightness. At 20 watts, the LED can glow up to 1600 luminance of brightness. Okay. Then material used here. For white color, gallium arsenide. For red color, gallium arsenide phosphide. For yellow and orange color, aluminum gallium arsenide phosphide. For green color, aluminum gallium phosphide. For blue color, zinc selenide. For ultraviolet and violet, gallium indium nitride. As you can able to see, almost we are using a gallium material here. So the small composition of the dopant or the mixture of the dopant, or we are changing something the composition, we can able to make different colors of LED here. So this is the one of the beautiful advantages of the LED here. So the small changes in the composition, we can able to make a different colors of LED. So it can able, as you can able to see that operating voltage, so it is a small 2.7 to 2.90, almost all the LED we can able to blink. Okay, so which means that we can able to make that LED very much cheaper compared to that incandescent lamp because the small composition changes, it will change the color also and can able to operate with the same voltage. Okay. So in the case of sodium vapor lamp and hydrogen vapor lamp, we need a separate transformer for that. We need a separate we need a time to glow up more. Okay. And then application of LED, longer lifespan. So compared to incandescent lamp, so it will glow more than 50,000 hours compared to incandescent lamp. Efficiency, as we have seen, whatever we have given the input voltage, almost it can able to operate with that voltage itself. So it doesn't lose any kind of energy in that. So direction, we can able to propagate the direction of the light in a particular direction with the help of that epoxidants and reflective cavity. And color range, we can able to change with the help of the mixture of the dopant. We can able to change the color of the light. A small proportion can able to change the color of the light drastically. Then low heat output. I want to show you the low heat output with this two light here. Okay, I have switched it on. I will switch now. I'm going to switch off this, and I will show it to you that I will stop sharing here. Okay, say this. I have thermometer here. As you can able to see here, almost 113, 114 degree Fahrenheit for this incandescent lab. Let me measure this 98.0. So you can see, yeah, 98.0 for this. Even I can't able to touch it because it is almost high voltage 140, 114 degree Fahrenheit for this incandescent lamp here. Okay, let me share it with my screen here. Okay, then in my state I will have point to ponder. I think so, point to ponder. So we can able to make micro LED. With the help of micro LED, if the LEDs are combined to form red, green, blue color, we can able to make white color LED, or it can able to use to show, it can able to make a big screen with the uh, combination of LED. So it is one of the next level of this LED. So normally we are having epoxy lens like that. If we are making a small micro LED, we can able to make it with we can able to make with the screen. Then light dependent resistor. Light dependent resistance means so it is purely dependent on the resistor. Whenever the fixed value of the resistor changes, it can able to change. It can so it can able to change the input light whenever the light is cut on that light dependent resistor. So it can able to switch on the circuit or close the circuit. So it is mainly used in the burglar alarm in the case of light dependent resistor. So this is all about LED. What we have to remind here, a different color LED having a different materials are used, but the proposition of composition is very much near compared to other case of LEDs. So with the help of these material, we can able to make different colors LED. And operating voltage is also near same to this LED. Okay. So this is all about LED. If you have anything doubt in it, let me know in the comment section. I will clear your doubts. Thank you so much for watching this video.